we run in far too often to attackers using process camouflage. And we're going to talk a little bit about that as we go through, but incident response, in our incident responses, we see a ton of attackers trying to hide in plain sight, right? All too often, I hear about unprecedented attacks, right? The IRS attack, unprecedented. The attack on South Carolina tax records, unprecedented, right? Not just tax records. Every attack that I work, I swear the incident response, management wants to believe what? It was APT. Always APT. It's sophisticated and unprecedented, right? I'm convinced every time somebody in the media uses the word APT, God kills a kitten, right? Which is probably okay because I hate cats anyway, right? But look, let's get going here. Let's talk a little bit about, for the rest of us who aren't APT, and by the way, we see APT using these techniques. See, one less cat, right? Okay, so who am I? Proud A+ certification holder, aspiring CEH. I hope to pass on my third try next week. I took computer classes back in high school 20 years ago as an expert in QBasic and Windows 3.1. And I have 11 years of experience at Subway, which gives me an awesome up, right, for dealing with business units who want made-to-order security solutions, right? No, of course, none of this is true, right? But I'm way too tired of people putting their entire resumes up here. Obviously, just a spoof there. Again, if you don't know, just Google me. I've been around the industry for a while. Tons of incident response stuff, and we'll get going here, right? Hiding like a nation state. So Dooku 2.0, Kaspersky Media hoard that out this week. Pretty big, awesome. How'd they find it? Testing a brand new solution, right? And they found it in their own networks. Now, gotta admit, Kaspersky, that takes some balls to step up and go, hey, we were hacked. But the saving grace is we found them using our own products and we can protect you too, right? So they basically pulled a CrowdStrike, a Mandiant. A FireEye. Well, anyway, so they basically media hoard the thing out. Bottom line, Dooku 2.0, estimated $50 million budget. I don't know whether you believe that or not, but whether it's 50 million, whether it's 5 million, it was a sophisticated piece of code, right? Big framework here. Big in size too, because I think they said the thing was like 18 megabytes with all the plugins. That's a hell of a lot of malware, right? But look, a lot of attackers want the lobster. Unfortunately, their budget is actually printed in food stamps, right? So what are they going to do? The answer is probably process camouflage. You want to run your process and hide in plain sight. It turns out this is actually better for you in many cases, much more stealthy. When you try to do crazy code injection stuff, when you try to load a driver, for instance, you have to get code signing certificates. Or you have to find some exploit that allows you to load your driver, whatever. This is an advanced technique, right? We start doing code injection. Code injection's like teenage sex, right? Everybody remembers being back in high school, trying to do the first time, as it were, right? And everybody's come back in, you're that freshman in high school, like, yeah, no, totally, it was awesome. Look, bottom line, 3/4 of the people that are talking about it don't know what the hell they're talking about. It was just like back in high school where people were spouting off stuff they didn't understand. Same thing with code injection. Practically every incident response that I work, when we first go in, usually we're there because the folks on site can't figure out exactly what's going on. What's the answer? Code injection and rootkits. These also translate into, I investigated it and I found nothing. Therefore, it must be one of these other mysterious things that I don't understand. Hey, the antivirus companies, they've been listening, and they are putting tons of work into detecting these very stealthy methods, the code injection, the rootkits. When you try to do this stuff, you are much more likely to trip up antivirus. Much more likely. As opposed to simply running a process, opening the process list, that basically allows you to hide in plain sight. How many service hosts do we have in the system? Legitimate service hosts on a Windows 7, Service Pack 1, no third-party software installed. Yet nobody knows. That's the key, right? So if an extra one shows up, who are we to know, right? I'll talk to you a little bit about how to come through and figure that out here in just a moment. So what's process camouflaging? Really, it's just hide in plain sight, pretend to be a legitimate process. We want something a user or an administrator is going to say, yeah, that looks okay. You got a baseline, right? If I hear one more time, what's your baseline? Oh, that's what normal looks like. Well, do you have a baseline? Yeah. So it's normal. So normal stuff is what's in our baseline, and we can go to baseline now, right? In the middle of the incident? Probably not, right? We have to baseline beforehand. You can't know what evil looks like until you know what normal looks like. Unfortunately, normal varies per organization. go back and grab an image of your golden image, right? Go back and actually take an image of that, grab some data from that golden image so you have something to compare against. You can at least start whitelisting the things, unless your attackers are in your golden image, in which case I cannot help you. But again, if they're not, come back in, grab an image of the golden image. It's going to save you crazy dollars during an investigation. Crazy, right? Absolutely nuts. And if you don't have a golden image, that's a whole separate problem. Start standardizing your deployment process, right? It will save you, again, crazy amounts of money during an investigation. So again, I don't know your systems as a consultant, and I'll tell you that most of you don't either. That's just a reality, right? You guys in this room might, but I'll tell you that most folks don't know. First thing we got to do is talk about generic Windows stuff, though, because that's germane to every individual every individual deployment worldwide, regardless. We need to know process names. We need to understand parent and child relationships, normal process paths, where the process is supposed to run out of, as well as normal command line arguments. What command line arguments should we be seeing for particular processes? I only have 50 minutes, so there's no way I'm going to get through all of Windows, right? So I had to pick something to focus on. I'm going to focus on the chain that gets us to service host, as well as talking a little about service host, and I'll tell you a little more why I picked service host in particular. There's some more advanced stuff that we might want to look for as well. Know these first, and then once you've really got these down, this is kind of like taking Spanish 1 or Spanish 2, and then you move up to that advanced level. You know, you get into Spanish 3, Spanish 4. You start doing more advanced speaking. You want to be very fluent in Windows, and so the more advanced, what DLLs do we expect to have loaded into our processes? We had an interesting incident response a while ago where calc.exe was up and running and in an RDP session on a server, but it turned out that calc was loading network DLLs. Now, I've been using Windows Calculator for years, and I've never seen the option that says, check my answer on the internet, right? It just doesn't exist. And so calc shouldn't load network DLLs. It turns out that there was an attacker injected into the calc.exe process, which again, very, very stealthy. Calc.exe, legitimate signed Windows executable, pretty boring executable actually. Right? I want to look at the expected paths for DLLs. DLL hijacking or path hijacking. DLL side loading, as some media whoring companies have been calling it as well. Excuse me. Strike that from the record. Other companies that have been publishing a lot about this, again, talk a lot about this DLL side loading, where we have DLLs in unexpected paths, legitimate DLL names, but not on the Windows System 32 directory. And this actually is caused by or allowed by some legacy compatibility stuff that Microsoft still has in Windows. Why is it there? Because, as you know, once you put a feature in Windows, Microsoft will never, ever, ever take it out. Visual Basic, I rest my case. So we also want to look at when should the process start relative to boot time. Some processes start very early. Some processes, on the other hand, we might not expect to see starting late in the boot cycle. Service process, for instance, services usually start at boot. We usually expect to see those processes start at boot, not late after boot. And then, what user started the process? My desktop process should be running as my user. Calc should probably be running as my user. My services process should probably be running as a system user, definitely not a regular desktop user. So again, looking at what's normal. Who's batting first? What's the first process that starts after the system process? What's the first process that starts? First process we expect to see. Anybody? What's that? NT-boot. No, not quite. Services is not it either, but that's a very common assertion. All right. Separately, does anybody know the number of wickets that are required in a regulation game of cricket, the sport of cricket? That was actually a trick question. Cricket's not a sport, but for system, it's SSMS.exe. Right? SMSS.exe, right? So SMSS.exe, again, it's the first process that starts. Let's talk quickly about SMSS. It's the first process started for system. It's always owned by system. The parent PID is always 4 because it's always system that starts it, and PID 4 for system has been common for everything since Windows 2000. Should always be in System 32. Interestingly enough, there are multiple copies of SMSS that start up. You just probably won't see them. All right, so SMSS, there's a master process, and then every time you log in, and it's not just you, if you have a system that has multiple RDP sessions, for instance, you'll have multiple SMSSs kick off. And again, what's going to happen here is that one's going to start, that's going to be our master process, and then we have others that will also start up when you log in. It's responsible for starting brand new sessions. Now, there's going to be one session that starts on every Windows system anyway. It's going to kick off CSRSS, and then it's going to exit out. So we expect to see this normally anytime we're checking the process list. We're usually only going to see one. If you see a second one, right, there's somebody else RDPing in on the system potentially, right? So roll the dice, check it again, and if you get it again, where you've got two of them, somebody's playing a trick. This is a very, very common process for process camouflaging. Does anybody know why this is a really popular process to name your malware? So in Windows Server 2003 and Windows XP, if you right-clicked in the task manager on smss.exe and said kill process, end process, Windows said, whoa, I'm sorry, you can't do that. Because smss.exe is a critical system process, and if you kill it, Windows is going to go down like a bad prom date, right? And so they said, no, you can't do it. Now in Windows 7, it says, hey, are you sure? Right? Or Vista Plus, right? Nobody counts Vista because, anyway, right? So Windows 7 Plus, when you right-click on it and try to kill it, it says, I don't think you should do that, but if you really, really want to do it, you're okay, right? But Windows XP, Windows Server 2003, no goes. So smss.exe starts potentially our chain down, or starts our chain down to service host.exe. Talked about what good looks like, right? So which of the following DLL names are not okay on a 64-bit system, right? This again comes back to knowing what does good look like. So kernel32.dll, is that good on a 64-bit system? Or should we see kernel 64? Just by show of hands, who says kernel 32? Who says kernel 64? Who's afraid to answer? Yeah, there we go. That's usually the majority. So it turns out, even on a 64-bit system, kernel 32.dll is still the expected name. Still the expected name, all right? What about winninit.dll? Good, bad, indifferent? What do we think? May or may not be wanting, right? So this may have something to do with networking functionality. It turns out it doesn't. That's actually bad too. Yeah, WinINet, on the other hand, is legitimate, right? WinINet sounds legitimate, but it's not, right? So again, this process camouflaging thing, as we think about, how to hide in plain sight. This isn't DLL injection. This is simply naming my DLL something that looks pretty sort of legitimate, right? Kernel 64.dll, that's bad every day of the week. WinINet 64.dll, again, that's bad every day of the week, right? That guy might as well be wearing gang signs, right? So, again, we strike the three obviously bad, or as it turns out, not obviously bad DLL names, right? Strike those three bad DLL names. Again, the key here is understanding what good looks like. Right? I travel a lot, man. I end up in these shady I try to avoid the shady hotel rooms, but I end up in these hotel rooms in the middle of the night with the time changes. I end up watching really, really bad late night TV. And if you know late night TV, and I don't mean like Jimmy Fallon, right? Because anyway, neither here nor there. But if you pop open the History Channel or Discovery Channel, when it gets to be 3 in the morning, right, and you can't sleep, they are running some crazy, whacked out stuff that they wrote 5, 6, 8 years ago. And so I'm watching, I don't remember when this was, it's been a good 4 or 5 years ago. I know this because I was watching the History Channel and they were still playing history, right? And today it's all about cars and pawn shops and whatever. But in any case, I'm watching this presentation and it was on the Secret Service, right? Does anybody know what the Secret Service does besides protecting the president? Counterfeit, right? So counterfeit. Yeah, so they do counterfeit detection. And they did a little study a while back. It turns out that the Secret Service has a huge counterfeit detection problem, or had at least. About 10 years ago, they found out that they absolutely sucked at doing it. They had two types of agents. They had the guys that were absolute rock stars in their counterfeit detection unit. They had rock stars, and on the other hand, they had rocks. And they went to the rock stars and they said, hey, what makes you a rock star? If you've ever done that for one of your rock stars on their team, you say, hey, what makes you so good at your job? Odds are good they can't tell you, right? They wake up in the morning and they're good at it and they just do it, right? And then they went to the rocks and they said, hey, what makes you suck so bad? And if you've ever tried that approach, you'll also know that that doesn't work very well because usually they get flustered and they're like, I don't suck that bad, right? Okay, so So what's the government to do? Well, they went and they hired a bunch of educational psychologists because commissioning a study is government's answer to everything. And the educational psychologists came in and they sat with the rocks and they sat with the rock stars and they came back after a 3-month period and they presented their findings to management. And the findings were absolutely horrifying. And they said, your rocks in your counterfeit detection unit do not know what money looks like. Let that sink in for a minute. Your job is counterfeit detection, and your agents don't know what money looks like. And they said, no, it can't be the case. I know what money looks like, and I'm a counterfeit detection agent. Now they said, okay, hold on a second. What we really mean to say is that the way you train your people is all wrong. And the way that they were training their people, their rocks, it turns out, could go out into the field, and if they had seen in training a particular counterfeit technique, they could see it again through pattern recognition. They could say, oh, I see that technique. I've seen this before. This bill is also using this technique. Therefore, it is counterfeit. And so what they did is they trained them on the top, 20, I don't know what the number was, 20 or 30 counterfeit detection techniques, and the rocks could go out into the field and they could spot those and nothing else. The rock stars, on the other hand, actually knew what money looks like. Crazy concept here. Actually knew what money looked like, and they were able to come in and regardless of what what technique was being used for counterfeit, they were able to detect the bills were counterfeit. Why? Because it didn't look like money. If you know what money looks like, everything that's not what money looks like is suspect. Why do I bring this up in the context of process camouflaging? This is exactly what we're talking about, right? I could show you a few bad names of DLLs. I could say, for instance, kernel64.dll is a bad name. Write that one down. Someone might try to use that, and they have. And you could then say, okay, anytime I see kernel64.dll, I'll be good. The problem is there are infinite variations of this. I had kern32.dll, kernl minus the extra e there, right? So kernl32.dll. I dealt with that one as well. Again, there are infinite variations of bad, but once you know what good looks like, everything else is suspect. Today in InfoSec, we train exactly the wrong way. We're doing basically Secret Service counterfeit detection a la before the government commissioned a study, right? Probably we should learn what good looks like first, and then everything else ends up being suspect, right? Learning what good looks like, despite being a little bit difficult at the outset, it turns out to pay huge dividends on the back end. So what about wininit.exe? Notice here, wininit.dll. Right? We've seen wininit.dll in a number of cases because, again, it looks good. Wininit.exe, legitimate process. Wininit.dll, all kinds of bad. Right? Always owned by system. It starts very, very near boot time. The parent varies. It's going to be a low PID. Really, its parent is smss.exe. Remember, I told you there are multiple copies of smss.exe. So that master stays running all the time. That child kicks off, and then it fires off wininit, and then it moves out, right? It goes ahead and exits itself. It's going to be already gone. The path's going to be in system 32. Shouldn't have any arguments. It should be a singleton. What do I mean by singleton? I mean that there shouldn't be multiple copies of wininit running. And then wininit spawns services. And again, I'm not going to cover every process out there. I just don't have that kind of time. But services starts. By the way, I don't have that kind of time, but I do have posters that cover all the common processes and what they should have running. When we're done, come up and grab one or two for your organization. Take them back with you. But again, services always owned by system. The parent is going to be wininit. All right, so. The path, again, system 32. Again, services should always be a singleton. There should only be one copy of it. Ran a great incident response a number of years ago. We were doing some insurance work for a company. And basically, this was in the dawn, we'll call it the dawn of cyber insurance. All right, so the dawn of breach insurance. And breach insurance is getting really interesting right now. I don't know if you guys are following the news, but there's a great story right now where this company made certain attestations about their security in their network. We patch, of course, you're lying. We have great user training. We have all kinds of awesome compensating controls in place, and then they got breached. And they lost a bunch of data, and I believe the settlement's somewhere in the $4.2 million range, if I'm not mistaken there, and a healthcare company, and essentially the insurance company came back and said, you said you're doing all this stuff, but a quick audit yields that you're not doing any of this stuff. we insured you at a particular rate based on, I insured you at a particular rate based on the fact that you said you were doing this. If you weren't doing it, we wouldn't have insured you in the first place. Now, the insurance company failed to audit ahead of time, right? This obviously is a big failure of theirs, but on the back end, they're like, sorry, we're not going to pay. And now there's a big court case going into whether or not they're going to have to pay out. Again, backing up here, we're doing some work with a insurance company a number of years ago, trying to decide whether or not they're going to insure a credit card processor. Hint: if it's a credit card processor or you're in insurance, don't insure them. They're going to get breached, right? History tells you that's going to be the case. But we go in there and we find C Windows System 32 service.exe, that service is service.exe running. I said, wow, this is all kinds of bad. We had gone in to do data collection, and then we were going to do the analysis on the back end, but this was just so obvious. I mean, it red flagged immediately. And I went to the app, and I'm like, hey, we've already got a problem. I mean, we didn't even have to do any hardcore data analysis. We have a problem, and this is, by the way, on their black network where they're actually doing the card transactions. And the guy's like, no, service.exe is totally legit. And we've got into this, like, basically this big headbutt match, and, it came down, I was like, no, you have to know what normal looks like. I mean, you have to be able to detect the evil. Regardless, services.exe good, service.exe 100% bad. Service host. Usually, again, the start time is going to be near boot time, right? Calc.exe, on the other hand, start time is not near boot time. It's sometime after the user logs in, right? So simply by looking at when a particular process starts up, again, we can get some indication. Service hosts, again, usually start near boot time. It is the rare legitimate service host that starts up long after the user logs in. It just doesn't happen often. There are some really weird fringe cases for backup, poorly built backup software, Altiris, that happen to run into problems like this, right? And that's an older version of Altiris, by the way. But arguments, it always has a -k argument. If you see a service host without a -k argument, you look at the command line, it doesn't have a -k, it's bad every day of the week. It's not parented by services, it's bad every day of the week. We'll walk through the 6 commandments of detecting evil service hosts in a minute here. So why am I covering service hosts? I like to think of service hosts as Smirnoff Ice of Windows process investigation during IR. Right? Smirnoff Ice is this. If you haven't seen Smirnoff Ice, you probably have, right? It's cheap. It's always at the party. I don't know who keeps bringing this and putting it in the cooler because nobody ever freaking drinks it, right? It's there, well, sometimes they do, but it's like the last thing to go. It's after you float the keg, everything else is gone, and you're like, man, I gotta keep my buzz going. And you look in there and you're like, Smirnoff Ice. You're like, I could just sober up now, right? Bottom line, everybody sees it. It's kind of like your service host. You look at it, you're like, service host, you're good to go. This is the way people treat this during incident response. And I apologize if you think Smirnoff Ice is awesome. Not because I apologize for hurting your feelings, just because you have bad taste. I'm sorry you enjoy such bad alcohol. Oh, that didn't work well. So again, what's the plan, right? If you're not familiar with the Underpants Gnomes, they had an awesome plan that was missing step 2. This is the way we see incident response work in general, not just related to service hosts, but in general. Again, we acknowledge the existence of all these Windows processes, and we're like, those are probably legit. We don't need to investigate those, right? Too many folks that I work with, I swear, they open up the process list, they start looking, and they're looking for malware.exe. And if malware.exe isn't there, if your attacker wasn't 100% brain dead, or botnet.exe, like we saw in a case, Again, if you're using botnet.exe as a pen tester or an attacker, try harder. But normally, again, here, we don't want to simply skip step 2. Just flat out don't investigate and just assume that we're going to be good. Let's talk about rogue service hosts, right? So we have 6 rules for finding rogue service hosts. We find these all the time. If you haven't heard about PlugX, you're probably not reading the news. PlugX is a huge. In fact, we blame PlugX in the use of, or some folks are attributing PlugX use in the IRS breach, right? In the IRS breach recently. And so PlugX, again, uses very frequently rogue service host processes that you can detect using these techniques, right? So again, this is right up to date, and I've been seeing this stuff for the last decade. PlugX is not a decade old, but again, these techniques are. Right? So the first commandment, thou shalt verify the running path of all thy service host processes. Because way too often, we find one running out of the temp directory. That's a bad, matter of fact, any executable running out of your temp directory is probably a bad thing. But if it's a service host that's running anywhere other than System32, I promise you it's fake. All right, promise you it's fake. Now, I love memory forensics. I've been doing memory forensics since long before memory forensics was cool. Way before memory forensics was cool. I worked with a company back in the day called HB Gary. How many folks heard of HB Gary? How many folks heard of HB Gary before they got hacked? Okay, usually the number of hands goes down. I have to tell you, I didn't do any security at HB Gary, right? So full disclosure, but I did do a lot of memory forensics stuff and malware detection over there. I love memory forensics. One of the reasons that I absolutely love it is the harder you try to hide, the more you stick out. All right, so it's almost like by the attacker trying to hide, they shine a freaking bat signal down on the badness. That's what we want. Right now with the attacker trying to hide, when we start doing live response, the attacker starts standing out more with memory forensics. Again, it makes them that much easier to find. I also like the fact that if I do have one of those rootkits, remember rootkits and code injection, oh my, right? So if I do have a rootkit on the system and I'm doing live response commands, the rootkit gets a chance to hide from me. It gets a chance to make the operating system lie to me. How many people flew in here for the conference? Yeah. When you went through the body scanners, did you guys opt out? Yeah. Opt out? A couple of folks opt out. You're like, yeah, rock on, right? Most security people are like, hell yeah, I opt out. 3/4 of them don't really, but at least they say they do, right? Look, regardless though, we get, we go through the TSA line, we don't try this, by the way. I'm a professional, but don't you guys try this. I promise you it turns out poorly. When you go up to the TSA, don't ever say, for instance, hey, I don't need to go through the body scanner. I'm not a terrorist. I just wanted to let you know that now that we've tested that I'm not a terrorist, I'm going to go and walk around here, right? TSA doesn't walk up and ask you, hey, are you a terrorist? No. Okay. Look, every terrorist can answer that question. The reality is, though, when we start doing live response and we ask the operating system in live response mode, hey, are you infected? Do you have rogue processes running on your system? Will you tell me the paths of all the service host processes that you have running? The operating system gets a chance to lie to you. Just like the TSA doesn't ask you if you're a terrorist, it makes you stand in the nudie scanner or pat you down in inappropriate places anyway. We need to do the same thing with our memory images, with our system. So I prefer to take a memory image and then go ahead and grope the system a little bit, just like the TSA does if you opt out. All right, so we want to verify the running path of all the service host processes, but if you have to do it live, I also have the commands here, and I'll publish these slides online here later this afternoon, so you have the commands as well. But again, WMIC, I know there's a lot of people that love PowerShell, and I love PowerShell too, right? Why am I not using PowerShell? Why am I using WMIC here? The reality is that lots and lots and lots of organizations that I work with are still on Windows Server 2003, are still on Windows XP, and many of those do not have PowerShell installed. And nary I tell you that many organizations that I work with, and I'm almost embarrassed to say this, are still running large enclaves of Windows Server 2000, and that definitely doesn't have PowerShell installed. This works regardless, and it works remotely regardless. And so I'm going to verify the running path of all thy service host processes. First commandment. Second commandment, I want to verify the parent PID of all thy service host processes. Services.exe should always be the parent. Always, every time. If it ever isn't the parent, I guarantee you have a problem. Right? So we're going to look for services. We see that the PID there is 520, and then we're going to look at the parent PID down for all of our service host.exe processes. Of course, I could script that out a little bit better, but it wouldn't be nearly as pretty there on the screen to be able to see. And again, if you have to do this live response, I'm going to go use task list to go find the PID of my services process first, and then I'm going to go look at the parent process IDs using WMIC. Unfortunately, Windows doesn't make this easy, right? So this becomes a two-step process. But again, there's a way to do it here for live response. With built-in commands, because again, I run into places a lot where I can't install new software to do incident response, which is again, absolutely mind-blowing. Even if it's a simple non-install, just bring my own command line with me. Yeah, again. Thou shalt verify the command line arguments. These -Ks, again, if you find a service host without a -K argument, I don't know when the Chinese are going to get onto this, because plugx doesn't use a -K argument. It does use two arguments. It actually will take two integer arguments with its service host that it creates, the fake service host. The fake service host plugx creates, by the way, is a Windows System 32 service host.exe, but it fails this. Right? You'll look and you'll see, and there won't be a PID there. I meant to grab a plugx image to show everybody, but again, it won't be. You won't see the parent PID being services.exe. So plugx, we've caught them by the second commandment, right? By the third commandment, we know something's wrong, right? They failed two required tests here. We don't have a -k, won't have a -k argument, but these are all legitimate service host.exes, or at least we believe they are up to this point with the -k argument, as well as having some service group behind. So again, popping through for memory forensics approaches. And then again, if you wanted to use live response, WMIC can also offer you that option. And so WMIC, if you notice here, has executable-like service host. WMIC has a query language, much like SQL, WQL, or Windows query language that you can use to get a little more granular results. It's the fourth commandment. Thou shalt verify the user running all thy service host processes. Incidentally, many of the fake service hosts that we see are not being run by the system or local system or network system user anyway. They're being run by administrator. No, it's wrong. Bad. Every day of the week. Right? Being run by local user because it's running out of the user's temp directory. Again, bad every day of the week. We don't want that. We want to make sure that, again, we're seeing at least the local system user or a regular system user, network service, net logon, something with all of our service host processes. Our memory forensics tools don't make this particularly easy because it lists all of the SIDs associated with a process, but this first one is actually the owner of the process. So again, we're going to pound through that. Unfortunately, I don't have a live response built-in command that makes this easy. Right? PowerShell, yes. WMIC, no. And so, just toast. Fifth commandment, thou shalt verify all thy service host processes are actually hosting services. Holy goodness. This is one where every attacker I've ever seen has failed. If they're creating a fake service host process, they parent it by services, they've thrown a -k argument, everything else looks good, and then you check and you say, okay, you're a service host. Logically, you should be, I don't know, hosting a service. My mom is awesome. My grandmother, actually, let me back it up a little bit more to the technotard end, right? My grandmother, God rest her soul, if you hand her the service host, you say, there is a service host process. What do you think, Grandma, service host does? She would say, probably hosts a freaking service, right? Okay, she wouldn't have said freaking. She was actually very foul-mouthed, but I won't repeat it here. Bottom line, I should say host a service. If you have a service host not hosting a service, it's guaranteed to be bad, right? Attackers screw this up a lot. Even our best attackers, our APTs, our nation states, they get everything else right, they get this one wrong. Right? They get this one wrong. And so we're going to go through and look and say, with our service scan, we're going to scan through memory to the service controller. We're going to identify within the service controller what services, right, what services are running. We're going to look for those. We're going to look for those there, and we're going to grab a list of PIDs associated with the service controller. Once you grab a list of PIDs associated with the service controller, we'll cross-check those against the PIDs we found earlier for the service host processes. Hopefully then, that works out there. Again, I don't have an easy way to do this short of writing some bash script, but hopefully that works out well enough for you. So again, we can do the same thing here with live response. It turns out task list, very familiar command to most people, has a secret switch called /svc. And this shows the services associated with every executable running on the system. This is awesome. I use this regularly. And again, this alone, this one command alone, is enough for you to detect rogue service host processes launched by plugx. If you take nothing else away from today, this is it, right here. Task list /svc. It's on everything since Windows 2000. That switch is on everything since Windows 2000. Task list /svc, find string service host. If you find a service host here, and you look over here and it says m/a, I promise you, whatever that thing is bad. We need to use some other techniques to find out what's bad or what's bad about it. How did it get there, right? Where did it come from? But it's bad. Sixth commandment, you gotta Google thy service host process service groups and ensure that thy Oracle knows about them, right? Use Google, period, right? I mean, the reality is we've got a number of service hosts, a number of service groups behind us there. The reality is that we've got to step back and try to find, are those service groups known? I've never found an attacker, and I mean this, in more than 10 years of doing incident response, and a lot of nation-state level incident response. I have never found an attacker that gets through the first 5, but I know it's coming. Sooner or later, right, I don't let my guard down, because sooner or later, we're going to find an attacker that gets through the first 5 commandments. They actually create a new service group. They manage to get themselves into the, what looks like a legitimate service host. I want to make sure that I recognize my service groups. It turns out it's pretty easy, right? So when we start looking at our -K, when I'm talking about the service groups, these, RPCSS, look, once you do this 3 or 4 times, you'll start recognizing these, just like you recognize kernel 32, just like you recognized wininet.dll, not wininet, but wininet.dll, right? You'll start recognizing these as well. What about rundll32.exe? I want to change gears just a little bit, because rundll32 is another one of these awesome processes. People see it all the time, are like, yep, it's good. Is it good? Maybe, right? But I'll tell you this, rundll is absolutely not your friend. Absolutely not your friend. Kind of like that guy that always comes to the party and swears he's going to bring some beer but never really does, right? Or he does and he brings a 6-pack of PBR or Smirnoff Ice, right? Whatever the case is, the stuff that nobody's really going to drink, right? Or, even worse, the guy that brings craft beer to the party, because honestly, I probably got a bunch of craft beer fans, never mind. Turns out that's a bad one for InfoSec, because I am a snobby beer drinker. Anyway, so look, bottom line, rundll32.exe is used to host a DLL, right? It's just a tool used to host a DLL. Microsoft originally was trying to be lazy and allow you to launch control panel applets in their own process. It's actually the lineage of rundll. The problem is attackers use this a lot. One of the reasons that attackers use this is to be able to communicate with the internet without creating one of those neat little firewall pop-ups that even my mom knows something's wrong, right? When it says, hey, this new process, malware.exe, wants to communicate with the internet. That's bad. When it pops up and it says rundll32.exe wants to communicate with the internet, what do you usually do in one of those scenarios? Well, if you're one of my users, you click yes, right? Because that's what our users do. And I'm actually happy about this, because as a consultant paid by the hour, I enjoy doing incident response. However, right, for the rest of us who work in an organization that we have to protect, our users clicking yes all the time, probably bad. Okay. But supposing our users aren't mindless idiots, probably open up Google and they say, hey, is this a legitimate process? And what does Google say? Rundll32.exe is good, right? Microsoft owns it, Microsoft signed it, it's good to go. The reality is your users are never going to see that pop up, because every antivirus process out there whitelists it out. And if you're using one of those weird antivirus products out there that doesn't whitelist it out, your users already clicked on that before, because NVIDIA, thanks NVIDIA, launches their nice little control panel applet-y thing, their taskbar, NVIDIA control panel, launches inside of rundll32.exe. It has to check for updates, clearly, and so it's already been communicating out to the internet. Your antivirus product, however, when it says, should I allow this to talk out, it looks at the process name, not the DLL that rundll32 is actually hosting. So your attacker gets a free ride based on the choice that you've already made. Also, our antivirus processes absolutely blow goats when it comes to looking at signed executables, particularly something signed by Microsoft, right? This is almost like walking up to Barack Obama, hanging on to him and like, dude, let's go into the party. The Secret Service is probably not going to stop you, right? Malware does the same thing. It latches onto a common Windows executable. It's signed by Windows. It gets a free ride there. We have to identify what's a particular DLL hosting. This one's awesome, right? So this is a fair eat infection. We see rundll32.exe launching DLLs, hosting DLLs in my app data roaming directory. Your DLLs should never be in app data. I mean, no DLLs I've ever seen that were legitimate have ever been in any app data or any temp directory period. So for the win, there's one normal Windows process. I talked a lot about System32. Coming back and shifting gears a little bit, every process I covered earlier here, I said was in Windows System32. Felt like a broken record. There's one normal Windows process that launches out of the Windows directory and not the Windows System32 directory. What is it? It's not System. Got a Raspberry Pi to give away. Somebody help me out. What's the answer? Who said it first? Yep.
Explorer.
Oh, come on, man. Explorer.exe, absolutely, right? So Explorer.exe, right? Explorer.exe launches out of Windows as opposed to Windows System 32, but I have worked multiple cases now where we see Windows System 32 Explorer.exe also running. And admins, when I report it, they come back and I'm like, nope, you're wrong. That's legitimate. I know because I Googled it and said Explorer is a legitimate process, and I right-clicked on it and said it was written by Microsoft, and so I know it's good to go, right? No, it's good to go. No, it's not, right? I have time for a live demo, I guess, potentially here. We can go ahead and do that if anybody's interested and actually walk through a couple of these techniques. That means I actually have to move now, but I hate standing behind a podium. It drives me nuts. And I fell off of a stage at Blackout a couple of years ago. It was like twice as tall as this, so I'm kind of like, I have actual stage fright. And I don't mean like standing in front of people. I mean actual fear of stages. But I'm not sure if that's a diagnosed malady or, let's see here. Okay, so got a number of different virtual machine images here, or virtual machine images, memory images essentially. We call them VMEMs, VMEMs because normally when we're creating these, we end up usually end up using VMware when we're creating scenarios. One of the things that I absolutely hate about teaching memory forensics is that I have to create, there's no way to sanitize, data. You can't ever take a memory image from a live system and ever use that for a demo, because you have done something somewhere, and the system remembers that you have done something somewhere, and you'll end up finding it in the memory image someplace, right? It's absolutely maddening. I've come to learn over a decade, more than a decade of doing forensics, that every one of us has a freak flag. Right? Every one of us has a freak flag. Your computer knows about it, and so does your forensics investigator. Right? So in any case, here we'll go and pop one of these. We'll use the APT image, and so we like to use volatility here. Again, I like to use volatility because I don't like the operating system to get a chance to lie to me. I could pull up my infected machine. We'll use this apt.image and -f there. So we give it the -f option to tell it what we want to actually analyze. If it's not a standard, not a standard Windows XP Service Pack 2, you'd have to give a profile option. In this case, I just kept it easy, but we'll go ahead and type the whole thing out here anyway. So WinXP SP SP2 x86, and so again, that's superfluous here. But we're going to do a PS list and just get an idea of process list and get an idea of the processes running on our system. And of course, I get a lot of crazy wrap here because well, you know what? I can probably shrink the size of that. Trust me, it looked awesome before the screen resolution got resized for the. Let's try that. That's probably too small to see. Let me go one more here, and then we'll. There we go. I still get the screen wrap anyway. But you kind of see here what we're looking at. We've got our PID and our parent PID. I'm able to see my PID for services is 704. I'm able to see here that my parent PID for every service host, and I can go through and manually check these, or I could use egrep because I'm lazy. So we might do an egrep when we would say services or service host. And it's some of the same stuff that we were looking at earlier. This just condenses down our data. I've actually written some plugins for a competing product called Recall. The new version of Recall has a couple of bugs. Recall is a fork of the, if you're not familiar with it, it's a fork of the volatility project. If you're not familiar with it, you should get familiar with it because it is 10 times better up until this current release where there are some new bugs. It was 10 times better than volatility. I say this in the context of being able to keep your code running because in our lab rendition, we end up running now 4 different versions of volatility because every time they release a new version, our plugins break. And I have neither the time nor the effort to go back, or time nor inclination to go back and recode my plugins for each new version of volatility. Google is actually backing the Recall project. They ran into the same thing, and they said this is ridiculous. We're done. Turns out that the guy that they hired, one of their developers, actually was a core contributor to the volatility project, Michael Cohen. Regardless, I've written some plugins here that kind of automate some of this out, but they're not in volatility, and the new version of Recall that I downloaded has some problems, and so not demoing that specifically this morning. But again, look for that to get released here in the next, whatever, as soon as the bug that we introduced into Recall gets shifted out. So again, services and service hosts. Some of the other things that we might do, we might look for DLL list, right? So DLL list actually shows us all the DLLs in a particular process. And this is great if you want to go into a lot of detail. Remember I said before, as we start getting more advanced, we have to know the DLLs, that are running in our processes. Let's see if I can get the Windows host at. It's Mavericks. I'll quickly show you how to do that in a live, show DLLs in a live environment as well. Let's see. So with our task list, I showed you task list /SVC earlier. There's a task list /M option that will allow you then to see all of the DLLs in each process. And so, unfortunately, it doesn't put them out in a very easy to see, very easy to use manner. But it does allow you to search through the DLLs and get them listed on a live system. That's got to be worth something. My favorite feature of this, though, comes down to searching for a particular DLL. Like, for instance, if I'm looking for instances of networking DLLs in calc or something where they should not be, I might look and say wininet.dll, right? Wininet.dll, legitimate DLL, as long as it's in the right place, right? As long as it's not in calc, for instance, right? And so I can then show all processes that have a particular DLL. This comes in really, really handy when we find out that we've got some rogue imposter in our network, something like a kern32.dll. And I want to check on the system and say, show me all the things that have my rogue kern32.dll. And it says, hey, there's no tasks running, and that's a good thing. All right. So again, this becomes a very, very useful live response command. Now again, I talked to you earlier about the dangers of running live and trusting the output from our live response commands. But again, it's there, it's an option, it's a hell of a lot quicker than taking a memory image every time and running forward with that. So again, DLL list, pretty awesome here, but one of the coolest things about it is this little command line, because we didn't get this before, right? So we didn't have the command line of our individual processes. Let's come back and we'll run that again, and we'll grep command, grep command, and then grep service host. And this gets us the full command line of all of our service host processes, just the same thing as we saw earlier with WMIC. So, a couple of other things to look at potentially. We can look at our get SIDs. Get SIDs shows us and I'm going to pipe this to more because it's a crazy amount of output. Get SIDs is what I was talking about earlier, where we're able to see the users associated with each individual process. And so again, we can see here then the users associated with our individual processes. And if we wanted to show that they're not all system, we could look for Dora the Explorer. Yeah, so we come down to Explorer, and you can see the demo user. I remember I told you the first entry here is the actual owner of the process within the SID list, and of course that demo user is the one that actually runs the Explorer process. So it looks like I'm running right up on the end of my time here, so we can get somebody set up for. Sure, somebody's coming in here for the follow-on talk. So I'll go ahead and close it out here with. Let's see. That's really, from a demo perspective, we could walk through this. Matter of fact, we could spend actually days and days walking through and understanding and learning how to enumerate all the goods on the system. The reality is, this takes time. It takes a lot of time in the trenches to learn what good looks like, but it pays off. Right? Definitely pays off. And again, tell you that I've got posters up here. I was going to say one per person in case I have like a run on them, but grab 2 or 3, take them home with you. Take them back to your office because they're dual-sided. If you haven't seen the poster before, we didn't have these out at the desk. I don't know why. I have no idea why, but they shipped them in to me when I said, "Hey, please ship these in." For those who don't know, by the way, I am a SANS instructor and a co-author on a number of different courses. So SANS is nice enough to ship me in a bunch of posters. If you don't have one of these, take these back. Even if you don't work in a sysadmin shop or whatever, take a couple back for your sysadmins and put them on the wall. Right? It shows what normal actually looks like on a regular system. Right? And then on the back, it's actually got a whole, so again, a lot of folks will take two and put one up, basically hang on either side. I see these in a lot of security operations centers that we go visit and do incident responses for. Is that an endorsement? If they're still getting pwned? Probably, right? Because you're going to get owned anyway, right? You're going to get owned anyway. That's just the reality of life. But seriously, come grab one of these. And then I've also got the new memory forensics poster that just came out earlier this year. Put this one together. Actually did put this one together with Alyssa Torres, my co-author on the memory forensics. And so if you're interested in learning some of the Windows internal structures, again, we've got a nice pretty brain or whatever have you there, as well as the 6-step process for if you know nothing else about memory forensics, have no idea where to start, have no idea how to do it. This right here again is the easy button, right? That by itself, of course, is not where you should end your investigation, but it will jumpstart every investigation and at least get you moving down the right track. So please come grab some of these so I don't have to take them with me on the plane. And with that, I'll ask for questions and/or close it out. Okay, awesome. I'll go ahead and close out. Thanks for your attendance. Greatly appreciate it.